FST students, this little short video is I'll be working through the Chapter 3 test for those of you that struggle with it or may need some help on this. So these are the first four inequalities. And the big thing to realize is that in this first one, in 1a, there is no absolute value there. So basically we would just be solving this like a normal inequality. We're going to try to get that x by itself, so I'm subtracting 12 from both sides. Then I'm going to divide by -7. So if you're ever multiplying or dividing by a negative number, that is going to reverse the sign. So that sign becomes less than a +3. On the graph, we'd have an open dot at 3 and everything less than. 1b, we've got a fraction there. Again, no absolute value, no reason to rewrite anything. To get rid of the fraction, I'm going to multiply both sides by 5. And then I'm going to just get the x by itself. I'm going to subtract 8 from both sides. I have -2x is less than 22. Divide by a -2, which, as we just talked about, will reverse that sign. And so I've got x is greater than -11. It's going to be an open dot at -11, everything to the right of that. 1c, you can see this one does have absolute value in. So here we need to think about isolating and rewriting. So the first thing I'm going to do is I'm going to add 5 to both sides. I'm going to divide by 2. And now the absolute value has been isolated. So now our step is to rewrite this. I'm going to rewrite this as x minus 3 is greater than 6. Or x minus 3 is less than -6. If I solve each part of this, I get x is greater than 9. Or, adding 3 here, I get x is less than -3. This is a splitter. We're greater than 9, and we are less than -3. Making sure you put that -3 and 9 in the correct order on the number line. 1d, you can see this is absolute value. It is already isolated. So I'm going to rewrite this. It's a less than. So I'm going to rewrite this as a tweener. So I'm going to put 6 minus 3x in between -12 and 12. And then I'm going to get the x by itself. Divide everything by -3. I'm dividing by a negative number. That reverses the sign all the way through. And so you can see I have everything between 6 and -2. Making sure I do this correctly, putting it in the order in which they are on the number line. I have closed dots because they're equal to, and I have everything in between there. So the key part here is don't rewrite anything unless you have absolute value. All right, second part of this is problem number 2, solving these polynomial inequalities. So for in 2a, I see we've got zeros at, in order, a -5, a -3, and a +2/3. All right, and then I'm going to test a point. You could also look at the shape of the graph of this, which is going to be a positive cubic. So I do know the shape of the graph is going to look like this. But if you tested a point, tested something more than 2/3, you'd find out that this makes it positive. And there are no double roots, so these signs should alternate in sign. All right, now here's the key to some of you that had trouble with it. At this point, we've got to look at what the problem is asking. And this is saying, when is this less than 0? Meaning, when is it negative? Sorry about that. So looking at the problem, when is it negative? It's negative right here when x is less than -5. And it's negative in between here, in between -3 and 2/3. And so those are your solutions there. Because the problem was asking, when is it less than 0? When is it negative? 2b. This one here, you probably don't want to deal with the shape of the graph at all. I'll do this strictly by test point method. Your zeros are -2, +3, and +4. And then testing a point greater than 4 would make everything positive. And now 4 is a double root, so it will bounce here and this will become positive. +3 is not, so then it changes to negative. -2 is a double root, and so that bounces and makes it negative also. All right, most of you got that part of this correct. All right, now we want to know, when is it greater than or equal to 0? So when it's equal to 0 is when it is the top equals 0, which when x is -2 and x is +3. +4 makes the whole thing undefined. So we're going to have an open circle there at 4. 4 cannot be part of your solution. Okay, now listing the solution. When is it greater than or equal to 0? Meaning positive or equal to 0. Well, it is definitely equal to 0 when x is -2. We have to include that. And then it's positive when x is greater than or equal to 3. But with that open dot at 4, x cannot be 4. And there'd be a couple different ways you could write that solution. But that would be the big thing. You've got to include -2. You have to include +3. And everywhere where it's positive, and you must include a +4. Uh, 2c. This one we're going to have to factor this. So we're going to take out an x, which is going to leave you with 2x squared plus 5x minus 3. And then, hoping this factors, this is a quadratic, so I'm going to start out with 2x and x. And I need to get factors of 3. I need to get a positive 5x in the middle. So a positive 3 here would give me a positive 6x and a -1. So now your zeros are a -3, 0 coming from this x right here, and then a positive 1/2. Again, making sure I put those all in the correct order. Now testing a point here, everything greater than a half would make everything positive. And there are no double roots, so these signs are going to alternate in sign. And now the question is saying, when is it less than 0? When is it negative? These would all be open dots because we don't want it to equal 0. When is it negative? It's negative when x is less than -3. And then as you can see here, between 0 and 1/2. And those would be your solutions there. The key there is getting everything factored completely and then using the test point method. So I hope this helps in reviewing for possibly a retake of this test. There will be a second part of this going through the second page of the